Okay, we're gonna continue the categorical variables. Okay, the last time I think we did the second approach, which is the label encoding. So we're gonna continue from there. I'm just gonna run this kind of really quickly from the beginning. So the third approach, which I would like to discuss over here, would be um, the so the first approach which is the simplest one, right? You drop the categorical variable. That's it. The column that has categorical variable or the columns that has non numerical. You just drop it. As simple as that, right? Very straightforward. No headache. The only thing that you have to consider is just to make sure your data is being pre-processed. Pre-processed in this case, make sure you separate the output, the Y, in this case the sale price, from the input, and then after that you make sure if any rows, so any horizontal rows that has missing values, you also put it down, and then you drop any columns that has missing values, right? So that's kind of obvious. But besides that, you're just gonna drop all of the categorical data. So you use basically this um, uh, comment, right? Okay. And then the second approach, it's why is it taking so slow? Okay. The second approach would be you use it's called label encoding, which is basically you encode. Encode means you turn text or words into numbers. That's what it is, right? Um, so you first, how do you do that? Um, Basically, you separate first the categorical data from the numerical data, and then after that, you turn the categorical data into numbers. Let's say 0, 1, 2, 3. Normally, this number is in the ascending or descending order in terms of like ranking. For example, if you have a categorical data about, for example, about temperature that says, okay, uh, hottest and then hot and then warm and then cold and then coldest, right? So if you convert that into numerical, it's going to be from like the hottest would be 0, and then hot would be 1, and then warm would be 2, and then cold would be 3, and then coldest would be 4. So like 0 to 4, right? Um, but there is an pre-processing method before you can do that. You want to make sure that because you have two data set from the training and validation, you want to make sure the unique values on the categorical data between the two data set, between the training and the validation, in this case, they are identical. What happens if you have non-identical values, for example, on the training data set, you have, for example, you have, again, the temperature as a features. Probably you have only warm, cold, and coldest, right? You have only have three values, right, on the training. And the validation, you have all the five values. You have the hottest, and then hot, warm, cold, and coldest. So if the case that the unique values between the two data sets they are not the same, then what you want to do is to, I think you drop it too, uh, because you otherwise you're gonna have an error, right? So in this case, if you look at the again, this is just a review. If you follow my previous session, you would know about this. a quick review on the condition 2. So we're inspecting condition 2, both, right? Under the validation data, if you look at here, norm is available in norm in the under training, right? So that's no problem. But RRAN is not available here. You cannot see RRAN here, and so is RRNN, right? So this is not good. So you want to drop this, right? That's the easiest method. The more difficult method would be to change to create like a those dummy kind of variable, those dummy values, so that it will be um, uh, available in both training and the validation in this case. And then the other thing, if you look at the MS zoning here features, right? Both in the validation and the training, you can see they're both identical, right? So on the validation there's RL and the training there's RL, there's RM, there's RM here, FV, there's FV here, RH, and there's RH here, and then the last one there's C as a unique values, and there's also C on the training under MS zoning, right? So in this case, this one is no problem at all, right? For the MS zoning, right? So um, so you want to drop that because you're gonna have an error because they're not the same, right? So how do we drop that? So first we're gonna divide there are gonna be two columns. One is those features, those categorical value that has the same identical values. Then you can call that good label columns, right? Over here. And then the other column would be it's all the bad one, the one that has a different unique values between those two data sets, right? So over here, if you can see here, just to recap really quickly, the the bad columns is this guy. So there are quite a plenty of them, right? So condition two is it's part of it. If we already take a look at it, um, there's gonna be like probably like 15 of them, probably bad label columns. Is it bad bad label? No, column. Um, can you count? No, cannot. There is no. It doesn't give. Oh, probably I have to give like that. Nope, it doesn't work. How about if I do insert, pop, remove, reverse sort? Nope. Okay. Anyway, you can count it manually. So there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's like about 15 bed label features or bit label column, right? Um, Over here, we are just doing the label encoding. So first, we're gonna drop the the um, the column that's considered bad label, right? And then we point it to label extract, right, over here. So we're gonna run this one, um, and then we're just gonna see the um, MA score, which is the absolute median absolute error or mean absolute error, which is slightly better. It's about 300 points better than the when you just drop the whole categorical variable, which is 17,800. Over here, we got 17,500. Yeah, so just a little bit better, right? So here's the third approach, which is probably the most complex one, is called one hot encoding. Um, the idea of one hot encoding is basically it's quite simple, right? So it's kind of similar to label encoding. Basically, it's just turning the turning text into numbers. Uh, but in one hot encoding, because the name is one hot, so is there's is only given one um, um, as a number on that specific location, and then the rest is going to be zero, right? So, for example, if you have, for example, again, we use a temperature as a column or as a features, and we have five unique values. Let's say warmest, warm, um, and then warmest, hottest, hot, warm, and coldest, cold and coldest, right? So we have five unique values in terms of temperature, right? So if you apply that into one label encoding, is going to be the warmest is going to be just zero and then one, two, three, four, right? It's quite straightforward. In one hot encoding, you're gonna apply. There are five location because there's going to be um, five unique values. So you give it like five digits number, right? That's probably with zero, 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 and only the values that are matching on that point. For example, if you want to one hot encode the value of the hottest one, the hottest is gonna be because the hottest is going to be is like on the most left hand side, so it's going to be 10000. That's going to be the code for the hottest. And how about the code for hot? It's going to be 01000, right? The code for um, so warm is going to be 00100. And then the code for cold is going to be 0000001 and 0, right? And then the code for the coldest, it's going to be, because it's on the fifth position, the most right, it's going to be 00001, right? So only the one that's on that location where um, the value is supposed to be kind of how do you say it, like attached to, then you put the value of one. The rest gonna be zero, right? That's the name is like one hot encoding. Okay, um, I hope you understand that. Otherwise, you can just go to Kaggle to see. It's pretty straightforward if you go here. Um, okay, so here's the example, right? So over here, red is over on the red column is going to be 1, the rest is 0, right? On yellow, only on the column of yellow is going to be 1, the rest is 0. On green, only the column of green is going to be 1 and the rest is 0, right? So so basically that's what I'm going to do. But before we can even do that, there's this thing called investigating cardinality. I think the idea of here is supposed to like uh, reduce space, because if you look at the one hot encoding over here, it takes a lot of space. So for three unique values, red, yellow, green, you need um, three digits number, right? So imagine if you have four, it's going to be four digit number. If you have five, it's going to be five. If you have 10 unique values, it's going to be 10 digit number, right? Um, and so on, right? Um, so I think this is what cardinality is all about. So cardinality is basically, okay, we're just going to read this together. So you've tried two different approaches, okay? Have you seen, as you've seen, encoding categorical data yields better results than removing columns from the dataset. And then soon you'll try one-hand encoding. Before then, one additional topic is need to cover. So I'm just gonna run this first. It says get number of unique entries in each column with categorical data. So this is the number of unique entries for the categorical data. So for the categorical data of street, they have two unique values. Could be, I don't know, street low and up, something like that. I don't know. For example, we take a look at for lot shape, there's four categorical unique values. Could be, I don't know, square, triangle, circle, or trapezoid. So right. I think this is the same. So this is for the training data, and this is the for the testing data. Yeah. Hmm. Street. This is there's something not right here. So over here, if you look at the utilities, only one, but over here there's two, right? Um, anyway, so we'll move on. So the output above shows for each column with categorical data the number of unique values in a column. For instance, the street column in string has two unique values, GRVL and pave, corresponding to gravel road and paved road. We refer to the number of unique entries of a categorical variable as cardinality. So that's what cardinality means. So street variable has cardinality of 2, right? The number of unique values. That's what basically means. Um, so fill in the blanks here. Fill in how many categorical variable in the training that have cardinality greater than 10. So if you look at the one greater than 10 under for data set for training, it's going to be this one, exterior first, exterior second, and neighborhood, right? So we have three cardinality number of columns, right? Uh, and then the next one is how many columns are needed to one hot encode the neighborhood variable in the training data. So for neighborhood over here, you have like 25, 25 unique values. I don't know, could be like, I don't know what is it called, like neighborhood rich, neighborhood poor, neighborhood fancy, neighborhood fun, neighborhood sad, neighborhood I don't know, like hilarious neighborhood, like I don't know what, but there are 25 unique values, right? Which means you need to have 25 digits number to describe that, right? So that's interesting. Okay, so we run that. Um, so over here is um, for just gonna read this together for a large data set with many rows. So like this one, how many rows do we have? Like 1,400, right? How many extra is um, let's see, extra shape. Oh, no, 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 no. It's not callable. Okay, so it's 1,168 rows, right? That's how many rows we have. So one hot encoding can greatly expand the size of the data set. So because just imagine, right? So for example, if you have one row, right? One row, um, right? And then you're trying to describe, let's say, neighborhood, right? Let's say I'm just gonna print this, the head, right? Right. So if we're trying to describe this neighborhood, right? Just one row, right? Just take ID 619, right? Right, this row, right? And then we're trying to describe this neighborhood. So we need, according to this, because we're using one hot encoding, we are gonna use 25, 25 uh, kind of columns, right? 25 columns, right? So, and that's just for one row. Um, so, so for this reason, we typically will only want hot encode columns with relatively low cardinality, right? Because if you have like say two column, yeah. So that's just for neighborhood, right? Not and then not to mention, for example, um, um, the other features. And then the more rows you have, right? If you have a lot of variable, categorical variable that has to be one hot encode because we're using one hot encode, then the number of rows are kind of like expand like a lot to be needed, right? Basically, right? So we because of this high cardinality columns can either be dropped from the data set or we can use label encoding, right? So you have two choices. Basically, you need to label encode it, or you can just drop it from the data set, right? So in this example, I think we're just gonna drop it, I think. So in this example, consider a data set with 10,000 rows um, and containing one categorical column with 100 unique entries, right? So if this column is replaced with the corresponding one hot encoding, how many entries are added to the data set? That's interesting. You have 10,000 rows. Um, and how many entries are added to the data set? So if you have 10,000, so every row with 100, how many entries? Hmm. Over here, I'm trying to answer it with 100. I don't think that's the case because there's 10,000 rows. Okay, if we instead replace the column with label encoding, how many entries are added? So if you just replace this, for example, this neighborhood, for example, you just assume this has a 100 unique entries. Um, how many entries? Just three, right? Is it three? Incorrect. So let's see about the solution here. Let's see the solution. What? So it's this guy. It's basically 1 e to the power of 4. So that's about 10,000. So that's like 10,000 rows. And then you multiply by 100, 100, and then minus 1e. What? I don't get this. Just by 100 and then minus 10,000. Why is it like that? And then the label entries is 0. How many entries are added to the data set by replacing the column with a label encoding? So you don't need any entry at all. Okay. Um, but if you use one hot encoding, um, you're gonna need this much. Oh wow, that's a lot. Yeah, I'm not sure about this. I have to think about this. My brain doesn't work. So I'm just gonna skip that. Assume it's correct. We're gonna go to the next one. Step four. We're gonna do the one hot encoding, but basically you want to just get the low cardinality columns, right? In this case, we are just gonna choose um, columns with cardinality less than 10. So, okay, so here's the, so you pointed to something, low cardinality columns, and then you call the columns on the object columns, which is just column based on categorical data on the categorical side, right? And then you put it on the X train, and then you count the number of unique um, uh, thing that they have. If they have has to be less than 10, right? The number of unique values. If it's less than 10, then you put that into the uh, an array of that are going to be pointed by this guy, right? So if we run this one, then low cardinality columns will be this array. So you have MS zoning, street, lot shape, line counter, utilities, and so on, right? Until cell condition. So these are basically all the columns that are just has less than 10 unique values. Well, we're going to drop this one, right? So we already know from here, right? We kind of know already from this guy here. Yeah, when we print out, yeah, this one, print out all of the unique values for each categorical value. So these are the three that we drop, right? Okay, so we already identified the columns that we want to work with, which is called low cardinality columns. And then next we're gonna um, do the one hot encoding. So we basically call the algorithm one hot encoder, right? And then we put this parameters: handle unknown, ignore, sparse equals false. Um, I think this has to do with sparsity. Probably later. I'm going to explain it later. So we are going to call the panda data frame, right? And then we're going to call the OH encoder, yeah, which is really the one hot encoder algorithm. And then we're going to call the algorithm called transform because we want to transform it. And what do we transform? We transform the um, training data set. But which training data set? Only the one that um, has a low cardinality columns, right? And then we put that into the a new pointer, right? The same thing that we do for the validation data set, the same thing. And then we put back the index because I think this one you take out the index for some reason. So you're gonna put it back the index. And then after that, we are gonna remove the categorical column because later we want to concatenate, right? Remember, this is just the contains or point to all of the columns that are categorical that are converted. How about the one that's the columns that are numerical, right? We want that one. We want to combine it, right? So that's why we drop first the column at, from here, the extract, and then we call it just a number. So this is column that's just pointing to the number of the features numbers. or do numerical numbers, do numerical features, sorry. And and then after that we add it up. So we call PD again, and then we concatenate the data between the number extract and the one that's being uh, encoded with the one hot encoding, right? The same thing we do for the validation. Okay, we run this one, and then so we can take a look at what it looks like basically. So just to show you what uh, after the conversion of the categorical data using one hot encoding. So this is what it looks like. All of these things here, right? So if you want to compare it with the one before the conversion, uh, yes, which has still categorical. So all of this, like this one, right? MS zoning, still categorical. Street, still categorical. Lot shape, still categorical. Line contour, still categorical, and so on and so forth, right? And this one already all being converted into one hot encoding. Yeah, so for this one, let's say ID is 619, which is this one. It's the first one is 00. Oh, I don't really, sorry. Um, but I'm still confused why it's like 00 and like this. It's supposed to be like 001, 010. Okay, anyway. And then we're gonna print the score. It turns out it's slightly better by but I think 10 points, kind of. So this is 17,525, right? One hot encode. The other one is only about, where is it? 75, right? So it's about 50 difference, like 50 points difference, which is um, okay. So um, one hot encoding is kind of the best one, right? It seems. Okay. And then the next one is you can submit this as but before you can submit it, you need to generate the test prediction, right? Um, so the test prediction, you need to convert it first, I think. So if this is the test prediction, right? Um, the object column should be the same, I think. I'm sleepy. Sorry. Um, I didn't drink my caffeine. I'm kind of like abstaining from my caffeine because they said it's not really good for long term for neurogenesis. So yeah. Anyway, so only if you have the time you want to do that. But since now I'm just my brain is already freezing out. It's not working anymore. So I have to end this session. At least we already discussed it until the how to treat categorical data using one hot encoding, right? So until next time, thanks for listening.